this one. Okay, how well do you know your conversions? If I have 1,000 meter equal to how many centimeter? Can you do that? What is the conversion? Yes.
100. No, 10,000.
Yeah, let's look at what we have to do. So maybe you want to write it down. So I know the biggest unit is, let's think about a kilometer first, okay? So 1 kilometer. Yeah, yes, it's here. Yes, help yourself. So if I have 1 kilometer, so equal to 1, okay, this is conversions. Okay, that's the first unit you need to know. 1 kilometer equal to 1,000 meter. And then we are talking about 1 meter equal to 100 centimeter. And 1 centimeter equal to 10 millimeter. Yes, that's what we are using at the moment. Okay, let's try some example. So the question 1, if I want you to find out 50 kilometer equal to how many meter? Question 1. So it's going to be 50,000, isn't it? Yeah, because it's 1,000 for 1 kilometer. If you times this by 50, that means I need to times that by 50. Good? Yes. And question 2, if I have 0.425 meter equal to how many centimeter? Okay, yeah, thinking from meter to centimeter, that means you need to times it by 100. So you do the same thing with this one. You times it by 100, so it's going to be 42.5 centimeter. Clear? Yeah. Okay, question 3. If I have 2,525 centimeter equal to how many kilometer? Right. So from centimeter, I cannot go to, at the moment I need to go to meter, and then from meter go to kilometer. So, and this is a smaller unit, and kilometer is a huge unit. From centimeter to meter, I need to divide it by 100, and from meter to kilometer, I need to divide it by 1,000. So that means I need to divide it by a total of 50. So at the moment, the dot decimal is right here. You need to shift it twice to get to centimeter and 3 more times to get to kilometer. That means I need to shift it 5 times. 1, 2, 3, 4, 5. So that is your number. Okay, try the next one. If I have what we are thinking is millimeter to centimeter. That means you divide by 10. Centimeter to meter divided by 100. Altogether, you are going to shift it 30 to the front. So, do you have it as 42.925 meter? Yep. Is that clear with it? Right. Now, you done with this. Now the next conversion set. Everyone is okay with this, right? Yeah, okay. Now, I'm going to change it to, instead of meter, kilometer, I'm going to change it to 1 kilometer square. Okay. Right, the unit you are going to have in here, because of the square, what you need to do is literally squaring this number. So in here you have 3 0. When you're squaring it, that means you are going to have 6 0. You double up the 0. And this is 2 0, that means you double up the 0. 1 0, double up again. That's what it means by the square. So now let us change the questions. Yes, log of 0, you are going to have, yes. Right, let's look at it one by one. So if you have 50 kilometer to meter is already 30. Now you need to square your 30. So that means 50, 30, and then double up. That's how many zeros you need to put in. And this one from meter to centimeter, that means you are going to have 100. Now you need to double the 0. So 100, that means 2 0, now become 4 0. You shift it to the right by 4. So 1, 2, 3, 4. Okay, now for this one, it's a big unit. I'm not going to think about the square first. From centimeter to meter, okay, centimeter to meter, that means 2 0. And then to kilometer, that means 3 0. So altogether, you have 5 0 in here. When you're squaring it, that means you have 10 0. You double up everything. So that means you need to shift to the front by 10 0. So far up to here is 4 0. You have 6 more to go. Clear so far? Yeah. And for the square, I'm not thinking of square first. So millimeter to centimeter, that means it's 10. Centimeter to meter is 100. So that means the number of 0 is 3. Now it becomes 6. So from millimeter to meter, that means I need to shift to the left by 6 0. So in here is already 5. 1, 2, 3, 4, 5. One more to go. So it's going to be 0.042925. Does it make sense? Yeah? Okay. More example? Yeah, okay, we'll go to the exercise.
Okay.
Okay? Yes? Okay. Right. And oh, one more. I did not write that. 1 hectare. Yeah. Equal to 10,000 meters square. Yeah, this is something special about meter square. Yes. 1 hectare equal to 10,000 meters square. So if I have 3 hectares, of course it's going to be 30,000 meters square. If I want to write 3 hectares in terms of kilometers square, what will you do? So first thing first, I'm able to change it to meter square, right? From meter square, then I change it to kilometer square. So what will you do from meter square to kilometer square?
Divided by
How many 0?
a million.
Yeah, 6 0. Because meter to kilometer is already 3 0. Because of the square, I need to double up. Right? Yes. Divided by 6 0. 1, 2, 3, 4, 5, 6. What do? Okay, always remember from hectare. You can't change to kilometer yet. You can't change to centimeter, but you change it to meter square. And then from there, you know your conversions on this side. Good? Yes, okay. Let's try to do some work. Any question, let me know. I will come out and help out. Yeah, this is our new stuff that we are going to do today. And the rest is all revisions. What are you working on at school?
Dot plus, like
Data.
data.
Okay, and you're
Frequency tables.
Okay.
Median, mean.
similar
Receiving, yeah.
topics, yeah. Okay with those? Data, dot plot, yeah. Looking good, looking good. Well done. You left on your 8.
Oh,
Yes. Okay, this one I think you miscalculated 0. How many 0 between centimeter and meter?
so
Uh,
10 down.
No, centimeter to meter. Do you have a square?
Oh, 1,000.
No. Look at that one. Meter to centimeter is 1 meter equal to how many
Oh, 100.
100. Yes, I think you are thinking of 100. So that means
So
how many?
100 squared is
Yes, double up to 0. 100 have how many 0?
2.
2.
Now it's 4 0.
Yeah, think of the 0. Don't think of it as a number. Because it's so hard.
Yeah, my pen's broken.
Oh, I see.
It's 10.
Yes, 10. Now,
Squared.
just 100. That's it. 2 0. That's it.
Also,
That's right. That's right. Yes. Just counting the 0. Shift the number of 0. Yes, that one. 4 0. Good.
using all these.
No. Oh, this is meter square.
Oh,
Yes.
oh, I see.
Yes, it's just that. That's right.
Good, good, good.
Good. A good double checking. Good job. Yes.
This one.
Okay, so first thing, what did you do?
I counted
You counted how many 0 did you start with? 4?
4 plus 4, which is 8.
Yes. That sounds right. That sounds right. Yeah. Yeah, that would be all right. That would be all right. Good. centimeter, how many zero?
2.
Two.
1 plus 1.
Yeah, 4 already, that means altogether should be how many zero? Yeah, going to millimeter square. So, meter, the next unit down is centimeter, so that means how many zero?
2
2, and then
plus 1
plus 1,
plus 3.
yes,
2, 3.
so that means how many zero altogether? Will be
3.
6 because of the square.
Oh.
Yes, you do the normal and then you double up the zero. Okay.
Am I allowed to use my phone?
Yes, you're allowed to use your calculator for it. Good. Yes. Good. Very good start. Yeah. That's right. Okay, where is the decimal at the moment? No, the decimal is, yes. And the other, you were right before. That's right.
No, thirds.
What did you say?
Thirds. Should I change it?
Take it to base 2 so you can add them together. So you have, what's the question? 16?
Yes.
To the power.
3x
Yeah.
times 2 to the power of 2x.
Okay, so the rules that we know, if you have a to the power 5 times a to the power 7, you can write as a to the power of 5 plus 7. Good. 5 plus 7. Right, that is the rule. But they have to be a. At the moment, this is 16. can you write 16 as 2 to the power of something?
2
2 times 2 times 2.
to the power of 4.
Good, 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 good. So I'm going to change this 16
Oh.
to, yeah, come in.
Yeah.
Yes. 2 to the power of 4. And then you have 3x times it by 2 to the power of 3x. And then what are you going to do in this step?
Oh, you times it.
Yes, well done. 2 to the power of 12x. Yeah. And then you can add it.
I need help.
Yes.
D.
Which one? D. Okay, minus 3. Okay, root. Yeah. Do root with you.
We did, but I think it was like this.
Okay, so. Okay, let's refresh the meaning of root. Root of 2. Oh, not 2. Let's keep it as a m in here. So how can you write this? This will be m to the power of, what's the meaning of root? To the power of,
Got it.
how do we put this in calculator? Oh, you do have a root. Yeah. Here, make sure you remember. When you have this, Sophie, yeah, this one, root, you can think of it as a half. Okay, so how about this one?
3/4.
Not quarter. What do you think about this one?
1/7.
Yes. 10?
1/10.
Yes. Now, let's change this one a little bit more. If I put a 2 in here, that means what will happen to my 2?
Oh, okay.
Yeah? Yeah? If I put a 6 in here, that means my 6 will go
On top.
on top. Yes, the one outside go under, the one inside go on top. Okay? Remember that.
So, how do you do when it's like 5/4?
Oh, 5 is just a 5.
Oh, okay.
Yeah, it's just a time. It's a 5 of just a 5x. So that means if I have a 5 in here, that means I have a. That's what I did. Yeah, it did nothing to the questions. Yep, it just stayed there. Operations. Which one comes first? Which 2 terms that? Yeah, you need to work out this one first, right? You cannot add
Oh,
first.
okay.
Yes, you need to work out that one first. So we are going to have x plus, yeah.
Is this an over if it's divided by?
Okay, this one you did not really properly. This is a plus.
Yeah, I combine these two.
You cannot. It's a plus. For example, if I have.
So is it just x x plus x to the power of
3
3?
times it by x to the power of minus 2.
Wait,
Wait.
because it says 6 divided by x to the power of 6 divided by 6 to the power of 3 is x to the power of 3, and then you subtract 2, which makes that just x.
Good. You make it just x. So that means.
That's 2x.
Yes, that's right. That's right.
I don't know what to do.
Okay, so what's the questions? Can you give me the questions?
X to the power of minus 3
Yeah.
times the cube root of x divided by 5
Cube root of x divided by 5.
to the power
Quadruple.
yeah
X.
x.
Okay, let's change it to term by term. Minus 3 times x to the power of third
Yeah, I've already done
divided by 5x to the power of quarter. Is that right?
Yeah.
Times means
that.
add. So that means I have x to the power of minus.
Minus 2 and 2/3.
Yes, minus 2 and 2/3 divided by 5x to the power of quarter. Right. And this is a 1 in here. Is that right?
Yeah.
1 divided by 5 give you
1/5.
1/5. This divided by that give you minus 2 and 2/3 minus a quarter. Is that right?
Yeah.
Yeah, you can put it in calculator if you want to. Yes. Oh, I left out my x. Sorry, I should have an x in here. I'm very careless. I did not write the x before I write that. So that will be x to the power of minus 2 and 2/3 minus a quarter. X to the power of
Wait. Oh, that's minus 8 on 3. Minus 8 on 3.
minus 8 on 3.
Minus,
Minus 8 on 3 minus a quarter.
which is minus 35 on 12.
Minus 35 on 12. Yeah, it's just a bad number.
Okay.
Yeah. Draw one line will do doing more. Otherwise, later if you want to check, you can't see what's underneath.
Okay.
Yeah. Yeah. Cross.
Oh, what's it?
Yep. Divide. What is that?
What does the right side?
Yeah. So that means cross up top and bottom as much as you can. Yep. That go once. That go. Yes. And then cross, yes. And also the x term. So that is a 5, right? Yep. That's 4. Because x to the power 6, that means x. You have 6 of them. X to the power 5, that means when you cross it out, left with only one of the x on the top. Is that right? Yep. Yep. Good. Yes. Good. So what's left on the top? What's left on the bottom? Nothing else, right? Yes. Over. Good. Yes. Done. This one should be a square. 3 square. Yep.
Yeah, that was a 6.
I mean, this number. The 3 to the power 3. Yes. Yes, that will change this number away. And the rest is all.
Can I go stop in there?
Yeah, yes, anything on the top and bottom can be crossed. Yep. Yes, cross it.
By whom?
Yeah, times it. times the top with the top, nothing to be crossed out already. Number. That's right. E to the power of. Still remember how to do it?
Yeah,
Yeah.
you have to find the numbers I multiplied together to make this one has to be like a square number.
Very good, that's the way, yes. One of them must be a square number.
I know, I'm trying to find it.
What are the square number? What is the first square number?
4 times
4. Yeah, you can start with 4. And what is the biggest, bigger than that?
Can I do it on 24
And then you, yeah, and then you do it again. Okay, to start with, refresh it, 32, that means one of the numbers must be a square number, that's right. So in here, 32, the square number will be 4, 9, 16, 25, 36, and so on. So one of the number multiplied must be from here, from the square number. This will be 16 times 2, that will give you that. So then you are thinking of root of 16 times it by root of 2. Root of 16 is 4, so I can write as 4 root 2. That's what you're going to do. So keep trying out. Try to have the biggest number as you can for what this side in here. Biggest square number. Yes. Yes, both of them having a root. This one also root. Yeah. 3 root 9. Yes. Root 6. So yeah. Okay. Keep going with this one. Minus. Okay. 96. What is the number you can divide by? Bigger than it. Can you add it? Yep, can you minus them? 3 root 6 minus 4 root 6 that give you? And this one give you? Right, can you simplify root 8?
No.
Yes. 8 can divide it by
2,
and
4.
yes. So 2 number multiplied to get to 8
Is that 44 root 2? No, yeah.
a bit too much. What are the 2 number multiplied to get to root 8? To get to 8?
4 and 2.
4 and 2. So when you root it, what do you get?
2 root 2.
Yes. That's right. You have 2 root 2 replacing that root 8. And then you times it by 11. So you get
22 root 2.
Wait, that's right, right?
Yeah, you don't write 1. Just write minus root. Yeah. That's right. That's right.
From this. And this one was 2, so that
Yes. Eventually
times
it
three.
become 4 later. No, this one become 2. Is that right?
Yeah.
Yeah. So that means 2 times 2.
is 4.
Yes.
Yeah.
So the next step. Okay, 4 and 2.
Is this a small one?
Yeah. Can you think you can get even bigger? 16 and 7 they are very big already. This one cannot go into prime number. This is a prime number. Yes.
Is it, I don't, wait. Wait, what do you mean? Is that the highest I can do?
Yeah. This is already a prime number. This number cannot get any bigger. Is that right? So that's it. You cannot. Yes, unless this is not a prime number. It's already prime number. You cannot get any bigger than that. Yes.
Yeah.
Root 3 times root 2, or else the root need to be bigger. Yes.
I don't know what to do after this.
If you have what will you get if you have root 2 times root maybe a 6?
I don't know.
What do you do when you have 6 times 2?
Root.
Root 12. So what is the other way? Remember root 32? 32 is
8 times 4, 16 times
16 times 2. Then I can think of that as 16. Can you see it? I go backward.
Yeah.
This can go to that. It can go to that.
So is that just 7 root 6 times 2?
Which is
7 root 12.
yes. And what can you do about root 12?
7 root 3 times 4.
That's right. Good.
I feel like that's
You cannot have plus. Why there is a plus? Yeah.
because I don't know what to do with this 14 minutes.
Okay. Right. Look at this one. Root 32. You have this times that, and then you can break into 2 roots. That means when you have 2 roots, you can join into 1.
Also, it's not
You-
plus, it's time.
Yeah, because it's the times. You cannot change the time to plus. You just work backward. Yes.
Yeah. Do I times the two together?
Times.
Like in this, do I times them?
Yeah, of course. You see, this is exactly backward.
Oh,
Yes. Yes. You cannot say I go backward and become a plus.
Oh, also, you can cross this.
Yes, anything top and bottom. term always can be crossed out. And okay, the other things, the root, if I have root 32 over root of maybe 14, okay, look at this, this one, when both of them are inside the root, that means I can write it as, remember this one I can split it, become 1, so this one I can think of it as that. That means you can cross. You can cross this with that as long as they're both inside the root. If I have 5 and 15, the outside can cross with the outside. This will be a 16, this will be a 7. Okay? Yeah. Okay, here's 84 comes from.
And times 6
Okay, look at that. What I just said. When the root with the root
Oh, I can.
cross. That's what that one is
So
for.
is it this?
Cross them as usual.
Oh, like this.
Yeah, the root.
Oh.
Root and the root can cross. Yes.
So this be answer.
And then what else can you do? Yeah. Oh, no, there's one is inside the root, one is outside the root. Yeah. You need to simplify a bit more. We never leave the answer as, can you times these two numbers? Yes. Yes. Yeah.
Oh, and 4.
Yes. Yes, good. Can you write root 8 as a square number? Or the two number multiplied to get to 8?
How do you, wait, is x-intercept just finding the x?
X-intercept is finding where does it cut the x-axis.
So do I have to just find x and y?
Oh, no. This is gradient intercept. Gradient intercept means write the equations as that. For example, y equal to 2x plus 5. That is meant by gradient intercept.
Mm-hmm.
Okay.
But is that the gradient intercept formula?
Yeah, that's what you need to do. Yes, right, in the gradient intercept form. Okay, if I have an equations, which is 3y minus 4x plus 9 equal to 0, if you need to write it in gradient intercept, and then y equal to 4 and 3x minus 3. That is the mean of gradient intercept form. Rewrite the equation into that form. This one's supposed to be 10 questions.
Oh.
Isn't that the equation code?
This is equations, this is equations. If you write it in y equal to a number times x and then another constant is called gradient intercept form.
Then let's find the gradient. The
Wait.
gradient's 3x, right?
The gradient is 3.
The y at 3, and then the x-intercept.
Yes. How do you find out y intercept first?
The y-intercept is minus 1 and 2.
Okay, to find the x-intercept, that means. So if I sketch this graph, remember how do we sketch it? We put this number in, minus 3 in here, and then I go up by 4, which is going to give you 1, and then I go across by 3, which is this point. Is it okay? Yep. So that means my line has to go through this one. To find x-intercept, that means I want to find out this point. Okay, to find x-intercept, that means what is the y-coordinate for this one? For that point, what is the y-coordinate?
0.
0, good. So something I want you to remember now, whenever you want to find x-intercept, what you do, you substitute your y as 0. Okay, this is a new concept I want you to remember. Because at this point, the y has to be 0. So that means your job is to replacing the y as 0 and then solve for the x. That will help you to find out the x-intercepts. Okay.
Okay, how do I...
Okay, I just explained that.
Oh,
When you have any equations, for example this one, if you want to write in gradient intercept form, that means I want to write it in y equal to something x plus a number. So for example this one, you can minus 4x, minus 9, and then you divide by 3 to each term. This is gradient intercept form.
so the... Oh, okay.
Remember that.
So, am I doing this right?
And then you divide every term by. Yep.
Okay. Wait, this...
Therefore your equation is going to be y equal to. Yep.
The central...
Yep. That's right. That's right. Yes.
This table,
Say again.
is this...
To find x-intercept,
Alright, so...
you put y equal to 0 into the equations. This is a line. Okay, if I want to find out where it cut the x-axis, what is the y coordinate for this point? 0. That's why y has to be 0 when you cut the x-axis. Okay, it doesn't matter when you cut the x-axis, your y coordinate have to be 0. Is that right?
Yeah.
So to find x-intercepts, you are going to put y equal to 0.
And then do I make X a subject?
Yes, that is how you find out the x.
I drew a plane.
Yep, you ignore your sign. Does it go up or go down? The equation, question B, when you draw it, does it go down or does it go up? The 4, is that -4 or +4?
Minus.
Yes, you cannot ignore the sign.
I forgot.
Okay, on the top, on the diagram, I want you to write -4. Here. This one. When you go this way, straight away there's a minus. That's why you go from left to right.
Thank you.
No, you do not need all of those.
Oh.
Where is your, to do the sketching here. Okay. -3 is the first point I put in. Here, look. Learn from here, then you change yours. The y, this is a y-intercept, right? So it cut it right there. Remember, this is the gradient, means rise, how much it go up, and how much it go to the right. It go up by 4, 1, 2, 3, 4. Yeah, remember? And then you go across by 3. That's why you are here. Then you join up a line. Yes. Okay, where is your y-intercept?
Oh, negative. Isn't it?
Y-intercept is -1/2. Yes, where is it? -1/2.
Oh.
Yep. Good. And then you go up by, what's the gradient?
Oh,
Go up by 3. And then go across by,
6. Oh,
3 means 3 over
1.
1. Yes, that's your point.
Okay.
Don't expect. The common factor is x plus 1. No, the common factor, what is the common factor?
X plus.
Yep, so x plus 1 is the first thing you write. In bracket. What do you left in here?
X
Yes.
2.
Yes, so you write open bracket. You left with x. Yeah, you cannot just join up become 2x.
I don't have a gradient like the.
Yep, the gradient. How much does it go up? so it's going to be 0 over,
5.
yeah, which is,
0.
yes.
So for this one,
Mm-hmm. What is the difference in here? What happened to,
minus
Yep.
4
and what happened from here to that? 5, yeah,
or something.
so what
So
is the gradient?
negative 4 over 5. Or negative 5 over
Mm. Alright, I want you to continue on the rest of it as your homework for this one and bring it back again next week, okay?
Thank you.